let's try and look at the modified Euler method, and let's try and estimate y of 0.1. And then the question itself says h is equal to 0.05, right? So this clearly means that you will have to go in stages, because if you observe the initial condition, that is very important, you are given y of 0 is equal to 1. That means your initial condition, that is x naught, is 0, and therefore when you predict using modified Euler method, you would be predicting it for x1, which is x naught plus h. Since x naught is 0 and h is given to be 0.05, what happens? Your prediction is actually for 0.05. That means you would be predicting y of 0.05, right? But what you have been asked to predict is for 0.1. That means you will go into one more stage, that is y of 0.1. In order to get y of 0.1, you will have to add one more h to this. That means y of 0.05 plus h, which will give you y of 0.1. That means you are going to predict it in two stages. First, you are going to predict for x1, which is x naught plus h, 0.05, and then you are going to predict it for 0.1, taking this as your basis. Then x naught for the second stage becomes 0.05, and h remains of course 0.05. Then you will be able to predict for 0.1, and a same situation can be given to Runge-Kutta process also. There also you would first start with x naught as 0, and then you will take that as 0.05 and then predict. And whatever y that you predict for 0.05, that becomes your y naught for your second stage of prediction. Very, very easy and clear. So how do you go about this particular situation? In fact, if you recall, in Runge-Kutta method also we have demonstrated very categorically how to carry out a prediction in stages. Here also we are doing the same. So now the first thing in Euler modified Euler approach is calculate x1 at which you are predicting. Note this very, very categorically. We are calculating x1 at which you are predicting your y. What is x1? x1 is nothing but x naught plus h. x naught plus h. What is x naught here? It is 0. You look at the initial condition carefully. And what about h? 0.05. And that is equal to 0.05. Right? This is the x1 at which you are predicting your y. And what about the next step? Here we calculate slope at 2 points. One is x naught, y naught, and also we are going to calculate slope at x1 comma y1 par 0. That means first we have calculated x1. We are also going to calculate y1 par 0. That means we are going to have this formula implemented, and once we calculate slope at x naught, y naught and x1, y1, we take the average of that, multiply that by h, and add y naught to make your prediction. Clear? The formula is clear. First you calculate y1, next you calculate y1 par 0, and then calculate slope at both x naught, y naught and x1, y1 par 0, and then take the average, multiply that by h, and then add to that y naught. Your final prediction is made. So now I have to calculate y1 to the power 0 in order to seek slope at x1, y1 power 0. So y1 power 0, how do you actually calculate? It is quite simple. It is y naught, which is 1 here, plus h is 0.05, and then multiply that by f of x naught, y naught. What is f of x naught, y naught? It is nothing but x naught, you know that it is 0 square. And what about y naught? Y naught is given to be 1 as per the initial condition. So exactly I am implementing this formula. Y naught 1 plus 0.05 into f of x naught y naught, f of x naught y naught. X naught is 0, y naught is 1. So therefore that turns out to be 1.05. Clear? We have calculated both the points to get our slope, and I also can calculate slope at f of x naught y naught and x1 y1 0, and then predict my value. So how do you predict that? y1 of 1, that means I am predicting this at what x? At x1, right, which I have calculated to be 0.05. You can see that. You can see that it is 0.05 x naught plus h. So therefore I am predicting it at x1, which is 0.05. Okay, so that is equal to what? That is equal to y naught, which is 1 plus h into average of two slopes. One slope evaluated at x naught y naught, another slope evaluated at x1 y1 power 0. So average of two slopes. What is one slope? X naught y naught. And what about x naught y naught? X naught is 0, y naught is 1. So that slope turns out to be 1. Because why I am saying slope every time? It is the definition of dy by dx of the curve that serves as the solution for this particular differential equation. The relationship between y and x is the solution, and dy by dx gives you the slope of that solution, and that is what is sought at x naught y naught. And now it is time to seek the slope at x1 and y1 0. y1 is known, x1 is also known. X1 is 0.05, so 0.05 whole square. And what about y1? y1 is y1 to the power 0 is given by 1.05. So this is f of x naught y naught, and this is the slope for x1 y1 power 0, and that, if calculated, because h is also known, 0.025, so that is 1.005 by 2. Here it is 1 plus 0.05 whole square plus 1.05, then that is equal to what? 1.051 approximately. So this is my first prediction, first stage of prediction, because what I am trying to do here is I am trying to predict it at x equal to 1, at x equal to x1, at x equal to x1 I am predicting, which is y of 0.5, because my x1 here is 0.5. So this is my prediction, which is y naught plus h into average of two slopes. Okay, as simple as that. Since we are taking average of just these two slopes, what happens? The Euler method is slightly less accurate, and it takes a lot of iterations for you to get a better accuracy. But of course, we are talking about very simple situations here. So now, can I improve this result for the first iteration itself? The question arises, for these simple cases, you don't have to reiterate. But if you want to reiterate, what you can do is you can use this whatever value that you have calculated here at y of 0.5, 1.051, the same value can be reused in this expression, replacing y1 power 0. And you will get a better estimation of y11, that is a better estimation of y of 0.05. What you can do, you can use this result in the calculation of slope of f of x1 comma y1 power 0. y1 power 0 can be replaced by this result if you want to get a better result, right? So this is the first stage of calculation. So what we have calculated essentially is y of 0.05, that's equal to 1.051. So that means what we have done here, we have done y naught calculation for stage 2, x naught calculation for stage 2. So this is my x naught, this is my y naught, and the procedure remains absolutely same because your h is 0.05 0.05. And the procedure, of course, remains absolutely the same. You calculated your x0, calculated your y0, you have a 0.05, calculate one more set of things. Now you are predicting at new x1. New x1, what is that? It is going to be your x0 plus your h, and that is 0.05. It is already there. You are adding one more 0.05. That means you are calculating your y now for stage 2 at 0.1. Whatever you are going to predict y11, it is at 0.1x, right? Remember that. Now what about y0? Y0 is going to be this, right? But in order to calculate, of course, for slope at this can be easily calculated because you know y0 and x0. But in order to calculate the slope at this, I know x1, which is 0.1, but I also need y1 to the power 0. How do you calculate that? That is easy to calculate, which is y1 to the power 0. This is for stage 2. Don't get confused it for stage 1. And that is equal to, I'm going to use my new x0, y0. Y0 is nothing but 1.051. Of course, the h does not change here. 0.05 by 2. H does not, just 0.05. It's not by 2. Here I'm not taking the average. I'm just making the computation of y, 0.05. And now I have to substitute x0, y0 in the function definition. What is x0 here? X0 here is nothing but 0.05. Okay. So 0.05 for whatever x you predicted the previous stage, that becomes x0 for this stage. And what about y? Y is nothing but whatever you predicted for the previous stage, 1.051, right? So this approximately becomes 1.1037. So now I have got my new x1, new y1 power 0. I can calculate this slope. I can also calculate this slope. And now I can predict my final y of 0.1. So how would I do that? That's quite simple. Now y of 0.1, which, how I am writing this? Because you can see here, this is being calculated for my new x1, which is 0.1. And you can also designate it as y1 to the power 1. So this is for second stage. This is equal to y0. Y0 is what? We have already calculated what in stage 1, 1.051. Okay, this is stage 1 calculation, don't forget. Plus h remains the same, 0.05 by 2. And what about x0, y0? Do not get confused with the old x0, y0. The new x0, y0 are 0.05. That is 0.05 is my x0. And then y0 is 1.051. Right? That's very important. Now, what about the slope at this? My new x1 is what? 0.1 whole square. And my new y1 to the power 0 is 1.1037. Remember, I'm evaluating slope at x1, y1, 0, and you can see y1, 0 by the same formula. Only thing is y0 and x0 are changed. So therefore 1.1037 should be added, because you see x square plus y, x square plus y. So that gives me the slope. And I take the average, multiply by h, and add it to 1.051. So that will give me my final prediction of 0.1 is equal to 55. Right? So this is what is my final prediction. So this is very, very easy. That is, I'm talking about modified Euler's approach. What you should do? Let me walk you through every detail. So the question that was given to us was to predict y of 0.1 with a step size of 0.05, and the initial condition I was given was y of 0 is equal to 1, that is x0 is equal to 1. So in Euler prediction, you always calculate the value of y for x0 plus h. That is, for x1 you calculate, and here x naught was 0, h was 0.5, so you calculated first stage for 0.05. In order to calculate, you have got to do two things. One, evaluate the slope at x naught, y naught, and also evaluate the slope at x1 and y1 par 0. That means you need two parameters. x1 is easy to calculate, 0.5, and y1 par 0 you calculated, that turned out to be 1.05, and this is the formula that we use. Y naught plus h into f of x naught y naught. F of x comma y is x square plus y, and if you substitute 0 plus 1, because x naught is 0, y naught is 1, 0.05 plus 1, 1.05, this is what you get. So now you can compute the slope at both the points x naught y naught and x1 y1 par 0, and hence you can predict y of 0.05. And what is the formula? It is simple. It is 1 plus, that is y naught plus h by 2. Why h by 2? Because you are taking the average of two slopes, multiply that by h, so h by 2 you get. And what is the slope at x naught y naught? It is 1, simply because x is 0, y is 1, right? It is simply because x is 0, y is 1, you get 1. And what about the slope at x naught and y1 par 0? y1 par 0 is 1.05 and x1 is 0.05. So if I substitute 0.05 whole square plus 1.05, so this 1 is the slope, remember, for x naught y naught, and 0.05 whole square plus 1.05 is the slope for x1 y1 par 0, right? So two slopes averaged multiplied by 0.05, which is the step size, I get 1.051. So which is the prediction for y of 0.05. And if somebody wants to improve this prediction, okay, it will improve by very, very small margin. What he or she could do is take this result 1.051, replace y in this slope calculation, that is this slope calculation. Instead of 1.05, they can use 1.051, so that can give you the second iteration for that calculation. But however, we are leaving it at that because it is going to improve by very, very small value, so we are not worried. Now I am interested in going forward and predicting for y of 0.1. I have already predicted for 0.05 of y. So what would be my new x1? Would it give me the result? Yes, indeed, because my new x1 will be x naught plus h. Now here my new x naught is 0.05, because I already predicted for that. If I added 1 h, I get 0.1, and that is what exactly is given. Remember, Euler's modified formula always gives you the result for x1, which is always x naught plus h, because x naught here is 0.05, because for that I predicted the value of y, and if I added one more h, I get for 0.1, which is exactly sought in the question. So now y of 0.05, that's equal to 1.051, which is my y naught, because I have already predicted. My h does not change, and the procedure remains absolutely same. Now once I calculate x1, I also need to calculate y1 to the power 0 for stage 2, because again I need slope at this point, take the average, multiply that by h, and add y naught. Now here my y naught is what? 1.051. So therefore I would first calculate y1 par 0 using that. So y naught plus h plus I'm going to find the slope at x naught y naught, that is for this. But now this time I'm not going to substitute 0 or 1 here. I'm going to substitute whatever I predicted in the previous stage for y, and for x it is 0.05, and that's what exactly gives me 1.137. This is y1 par 0. I have got x1, I have got everything to calculate my prediction for y of 0.1. So what I do, I come here, I substitute y naught, and then the average slope multiplied by h. H does not change for this second stage. So how do you calculate the average slope? First you calculate slope for x naught y naught. Now here for stage 2, My x naught is 0.05. My y naught is 1.051. So my slope is calculated, which is x square plus y. And what about using x1, y1 power 0? x1 now is 0.1, for which I am predicting. So that is 0.1 whole square. And plus y will give me the slope for x1, y1 power 0. And that's what exactly I have done. I have taken the average by dividing it by 2, multiply that by 0.05 and add y0, which is the prediction of stage 1, will give me the prediction for stage 2. If you want to improve, what you can do is you can replace this particular value y 1.1037 by this, and then you can recalculate for improvements. Otherwise, you can leave it at that. The improvement would hardly be recognized even if you carry it out for this simple situation. So therefore, the Euler modified formula is very, very clear. First, know your x naught, know your y naught, then you are predicting it for x1, which is x naught plus h. And how do you do that? By calculating slope at 2 points, x naught, y naught, and x1 and y1 power 0. How do you calculate y1 power 0? It is y naught plus h into slope at x naught, y naught. And if you use that in the final formula, which is y1 plus h into average of slopes at 2 points, you are home. And if you are given a problem like this, you will have to do it at 2 stages. Why? It is very, very clear, because your x1 for the first stage is 0 plus 0.05, and x1 for your stage 2 is 0.05 plus 0.05, which is 0.1. So that's what you are desired to find out. So that concludes the first problem. Let's move on and look at more discussions on Euler's modified method. Well, engineering and math are absolutely inseparable. We Innoventions, day in and day out, try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.